from CSE department. Okay, now I'm going to present a introduction related to the big data and its a framework and its ecosystem. Okay. So actually, here we already know about a few tools, that is Excel, Access, SQL, and this one SAS and R. Actually, this is for statistical analytics. For this purpose, the software suite is used. And so actually, here the point is how much time did it take? Okay, so however, so we have suppose an Excel file. Okay, so have we tried? Have we ever tried a table on 500 MB file in Excel? Okay, so have we ever tried to store or to process a file of 500 MB size, an Excel file? Okay, so as per the file related to the Excel, so it is somewhat large in size. Okay, in the same way, so in case of SAS or R, this is a statistical programming platform in this. So they ever tried a frequency table on 2 GB file. Okay, and also in case of MS Access, okay, we have ever tried running a query on 10 GB file. Okay, so 10 gigabytes of file size. In the same way in SQL, have we ever tried running a query on 50 GB file? Okay. If we tried all these, okay, in case of Excel or in case of Access or in case of SQL, these sizes, the file sizes are not adequate to run a query or to process it. Okay. Just if we take Excel file, okay, so up to now we handle about the Excel files which are there in some MB sizes, not even in MB, some kilobytes of a size. If we try to process a table or to process data of 500 MB, so actually it is very slow. The processing is very slow. Okay, and the accessing is also very slow. If you want to open that file and if you want to access the data, it takes some time. In the same way, in these examples, okay, they take much more time. But actually, we ever tried about these. So that's why the question is, how much did the time taken to do this? Okay, that is the one question. So in all these aspects, the file size is somewhat large than the traditional file sizes. Okay. Next, can you think of? It's also a simple question. So can you think of, or can we think of running a query on 20 lakhs 980, sorry, 2 crores 9 lakhs 80,000 gigabyte file, very large size. Okay. So can we think of running a query on such huge size data file? Okay. What if we get a new data set like this every day? Suppose we are having in our daily life, we're having this kind of a file or this size of a file to process. What if we need to execute some very big queries or complex queries on a data set every day, such type of file like this big size? Does anyone really deal with this kind of data sets? Or to think of it, whether it is possible to store and analyze such huge data? Okay. Generally in our systems, so this much size file is actually to store it, it occupies very so much space. Okay. So that is the question here. Generally, this thing is simply there in case of, so generally, so an example, Google deal files of 20 petabyte every day, 20 petabyte data. So that is stored and accessed and processed by the Google. So petabytes means, so generally we know we so frequently use the data sizes up to GB. Okay, so 1 GB equals to 1024 MB. So in the same way, so 1024 GB is equals to 1 terabyte, and so 1024 terabytes is equals to 1 petabyte. So in such a fashion, 20 petabyte data is handled by the Google every day. Okay, why I mentioned all such examples here in this sense. So in every day we are dealing with the data, so which is growing in size, so which is having very large in size, but our traditional data processing and our ordinary computers are unable to store them, and access and processing is a difficult in such cases. Okay, that's why we go for the solution. Before going to that solution, so look at this one more slide. In fact, in a minute, So what actually happened in the present world, actually in a minute. So in a single minute, so email users send more than 204 million messages, and mobile web receives 217 new users, and Google receives over 2 million search queries. YouTube users upload 48 hours of a new video. Okay, so Facebook users share okay, 6 lakh 84,000 bits of content, and like that. So all such, so these are such are the examples what happened in a minute. Okay, so and this data is a few years back information, so not even the current dates information. Okay, so in every day the data is generated by all the sources. So example, these are a few examples: Facebook, Twitter, so and all these are the examples, and they generate huge amounts of data. Okay, and finally the data is to be stored somewhere in the disk or somewhere in the storage. Okay, which means we are storing per minute huge amounts of data. Okay, and so in the first slide I mentioned that just a file, Excel file of sub 500 MB, it is difficult to access and process. It takes very much time. Okay, now that is different. And here in a minute, so much amounts of data is generated. Where actually we need to store? If we go for storing such data, so either the Google or Facebook or Twitter or Instagram, these media, so these are going to store the data in the so storage space itself. Okay, to do so they require mostly the buildings and totally space allotted for the computers and the servers. Okay, so to store this much of data, for suppose take just for a minute, Google receives 2 million search queries, 2 million. So much information. So if we take for month or per year, okay, so every year Google has to construct a new buildings to put their servers to store the data. Okay. If it is increased, if the so devices grows in number in this manner, then the world completely is occupied by the devices which are used to store the data only. Okay, so actually this is a problem. Okay. So the data is growing very fast, and we are unable to store the high size or huge size information, large data size files in our traditional processing softwares by using traditional processing softwares and our systems. So that's why this is a problematic thing. So the solution is there in the form of big data. What is big data? So your big data is a collection of large and complex data sets, so that are difficult to process using, okay, so using traditional database management systems or tools and traditional data processing applications. So a big data is a collection of large data sets. That means data sets whose size is very large, and the data present in is a complex. It is not a simple data, it is a complex data. And so the difficulty here is whenever you want to process it, the already available traditional data processing techniques, okay, so they are not enough. Okay. So file accessing mechanisms or database accessing mechanisms or even the data mining tools, so they are not enough, are not adequate, are not appropriate to process such kind of large and complex data sets. Okay. So that's why here the solution is in terms of big data. Okay. So the big data is the data whose scale, diversity, and complexity, they require a new architecture, techniques, and algorithms and analytics, so that are to manage the data in the big data and to extract some meaningful knowledge and a value from the data. Actually, in big data, the raw data is stored in a very huge size, so very big size. Okay. So big data, actually, the data stored internal to this big data concept is similar to the normal data called small data. Okay. So ordinary data itself, it is stored, but in a huge size. Now here, so the big data aim is to solve such kind of so big size problems. That means huge size problem. Okay. Whenever the data is in there in the very huge amounts, at that time to processing it, to access it, to store it, these are the difficulties. Okay. So to solve these difficulties, this big data concept is used. Okay. So the big data generates a value. So from the data storage and the processing of that large data. Okay, so that cannot be analyzed with the help of our already existed traditional processing and computing techniques. So up to now, before that big data we had, so data mining, databases, and normal file accessing systems, and these are not enough to access and store data of this very big size. Okay, now, so the big data is simply represented in terms of three characteristics, three important characteristics. They are termed as three V's. So three V's. So one is volume. That means it is related to the quantity of the data. And the next one is velocity. So it is related to the speed of the data that is generated. Okay, at which speeds the data is generated, and what is the data growth, at which rates the data growth is. And the next one is, next characteristic is a variety. That means variety, various types of data. That means various data types that are to be stored by using this big data. Okay, so the important and the three important characteristics of the big data are volume, velocity, and variety. Okay, so let's go to discuss everyone, each and everyone. The first one is the volume. So volume means its size. Okay, generally, so normal computers, so traditional or normal ordinary personal computers, they can store so up to the files of sizes some gigabytes. And mostly, if we take the high configured system now, so the present high configured system, it is having a storage space of some terabytes in size. Okay, entire one personal computer, the two a high-end computer, it can store some terabytes of storage. It is having some terabytes of storage, and so here a file itself is having some petabytes of size. That means a file, a single file of this big data or some huge size, it is not able to store in a single personal computer. Okay, so that's a fact here. That means, so what actually the big data handle, the size of a file, it is very, very large in size. Now, so actually in these days, Facebook generates 500 terabytes of new data every day. Okay. So Facebook itself generates 500 terabytes of data where it is to be stored. That means very large data. And so due to the modernization and due to the development in case of so electronic devices, okay, everything is instrumentized. Okay, so everything, so every organization, everything in the world is instrumentized. So that means we are using instruments everywhere. So those instruments generates information or generates data. Okay, so that kind of instrument generates data. And so one more thing, those instruments are interconnected through the invention or through the computer networks. That means the instruments are connected with each other, so they are sharing the information. Okay, that also generates so somewhat information. So due to the interconnectivity and instrumentation in the modern world, they generate very huge amounts of data per second or per minute. Okay. So take an example, Boeing 737. Okay, so this is a one flight. So this flight communicates with the base stations so frequently, and so the Boeing, this flight is instrumentized, which generates 240 terabytes of flight data during a single flight. Okay, and so take your smartphones as an example. So they create and consume very high information, not very high, so somewhat information, but throughout the world there are so many number of phones, smartphones everywhere, smartphones are used. Okay, and also some sensors embedded into everyday objects. Okay, as we know about the internet of things, so every object so generates information here. Okay, so like that, if we consider in this fashion, so everywhere in the world, so per every second very huge amounts of data is generated. That generated data is to be stored. Okay, so volume, so in terms of volume, this is a big data volume. So big data has to store the data which is generated at a high volume, so very huge in size. The next characteristic of big data is the velocity, so which means at which speeds the data is generated. Okay, so the data is generated at a very high speeds. Okay, so click streams and ad impressions capture user behavior at millions of events per second. Okay, suppose I'm I'm presenting these slides, and every time I'm going to click. So I'm going to click one button or one. So I'm going to use a mouse click like that. An internet browser, who can search so many links at a time, or is performing some clicks, mouse clicks. So everything is captured at the back end. Everything is captured. That means even if we browse the internet, so our data is captured somewhere, and that also generated in the form of some data that is also stored. Okay. So like that, high frequency stock trading algorithms. If you go for trading per second, so the situation is changing. The market present situation is changing in every microsecond. Okay. So if you want to put purchase stocks, so then it affects. Okay. So within a small amount of time, it is changing. That means data is changing in a microseconds of a time span. Okay. And machine to machine processes. That means machine is exchanging with other machine. Okay. So like that, there are so many number of devices which are exchanging at a higher speeds. Okay. That means if we consider in the world per second high velocity, the data is generated with high speeds. So like that, that kind of data is to be stored. The data which you are generating at higher speeds, the data is to be captured and stored. Okay. So in the big data, that is called its velocity characteristic and variety. Okay. The generated data is of different types. Okay, that may be numbers, dates, strings, so even some geospatial data, 3D, audio, video, so structured, semi-structured, so log files, and some other social media files. Okay. So these kind of data is not actually handled with the help of traditional databases. Okay. So why? Because the traditional databases or data warehouses supports some structured data. So their structure is in the form of a table or a somewhat a defined structure. But actually, big data captures the information which is having a wide variety of data types. So the analysis or the storage of the data is not possible with already existed database systems or data mining systems or traditional data processing systems. You know, so how to handle such type of big data now? Because the data is very large in size, that is generated at higher speeds, and it is having various kinds of data. Okay, to handle such big data, we are using parallel computing. Okay, let us take an example. There is a file of 1 GB text file now. So that is related to the status updates on a Facebook in a day. So now we are going to count the number of rows. So which takes 10 minutes. That means in case of 1 GB file, we are going to count the number of rows. It takes 10 minutes of time. That too by using an SQL query select count all from every status. Every status is supposed to take a table. This takes so actually very less seconds, but if we go for processing a file, it takes 10 minutes to count the number of rows in a 1 GB text file. Okay, what do you do if we have a 6 months data? It is just a day, 1 day data, 1 GB. 6 months means 6 into 30, 180 GB data, or so nearly 200 GB. Okay, but we need to perform that counting that takes same time 10 minutes. Okay, 1 GB file to count the number of rows, so it takes 10 minutes. In the same time, we need to count the 200 GB file. So generally, it is not possible with already existing traditional computing processing, but now we are using this one parallel computing. Okay, so that means we are using multiple CPUs in a single machine. That is, we are taking 100 CPUs. Okay, so each CPU, so the total file that is of a size 200 is divided into 100. That means each file, each part is having 2 GB data. So that the processing of such 2 GB data is assigned to one CPU. So in that way, it nearly takes 20 minutes to process the overall 200 GB file. Suppose if we allocate 200 machines, each machine take 1 GB. Actually, to process 1 GB data, it takes 10 minutes. Like that, by taking 200 computer machine, that means CPUs, and consider it as a single coherent machine. And by using these computers, if we process the 200 GB file, it takes 10 minutes, exactly the same time. But what actually here needed is we need 200 or 100 number of CPUs. That is, so the thing involved in parallel computing. The work is divided and assigned to so many number of machines. Okay. And here we are writing a code that will calculate 200 parallel counts and finally sums up. Okay. what actually the individual machine gives the output. The outputs are simply combined. Okay, this is called parallel computing. By using this parallel computing, we can handle that large size data sets. Okay. So handling big data, is there a better way? Okay. So actually, these are the statistics. It has, so till 1985, so there is no way to connect multiple computers. Okay. After that, due to the advances in case of systems, so are the invention of supercomputers and multi-core computers, and so due to the invention in 1985, that too, so the high-speed computer networks called LANs and MANs or WANs, okay, the computers are interconnected. That means, so the data is distributed and placed on different machines, and different machines can communicate. Okay, so this is a better way to do that parallel processing. Okay, each device is connected with the other. In that way, we can so distribute our work. So that is a distributed processing or distributed systems. Okay, now so to do this distributed processing or parallel computing, so the big data supports one framework. So that framework here is simply described in the form of a map reduce programming model, or it is called that map reduce framework. Okay. Here it consisting of two functions, map and reduce. Okay. The map function is called on every item in the input. Okay. So and it emits a series of intermediate key value pairs from that input. Okay. What are the required fields? So they are extracted, and so all values associated with a given key are grouped together. That means key is the same and the values are different. The values all are related to the same key. They are grouped in that form. It generates a group of values, key value pairs, and they are submitted to the reduce function. The reduce function is called on every unique key, and it's a group of values. And finally, it gives a single value as the output. Like that. So the map reduce framework for a big data problem, it is having so many number of map functions and some number of reduce functions. Okay. So to process 200 GB file, it takes 200 map functions and 50 or so 80 or some number of reduce functions. Okay. So like that, so the data is distributed across these map and reduce functions. Okay. So it is just not a map reduce. So actually in the previous example, we need to count the number of rows. So to count that, so just we need count equals to count plus one, this kind of a statement in our program. But actually here, what happens in the sense in the map reducing framework, we need to set up a cluster of machines, group of machines that divide the whole data set into so divide different parts and allot them to the local machines. And one of the machine act as a master, which takes charge of all the metadata and work scheduling and distribution of the data and job scheduling also. And so assign worker slots to execute the map and reduce functions. Okay, that means on the given cluster of machines, one act as a master and the remaining are slaves. They do the work. The work is allotted by the master. So, and it also consisting of the map reduce framework also consisting of the load balance. Whenever one machine in the cluster is very slow, then that work is allotted to some other ideal machine in the cluster. And fault tolerant. This is also one of the property of a map reduce. Fault tolerant means, so whenever so the intermediate so data is partially read and the machine which read the data partially is failed. So before it gives a output to the reduce function, it is failed. So at that time, the operation is completed with the help of another node, that means another machine, which can act as this particular one as a replacement. A fault tolerance, that is called fault tolerance. So finally, the write and map reduce code. So we need to write the map and reduce code to solve the problem of big data. So what actually the problem? To solve that, we need to write the code. Okay, this is a map reduce. Okay, now, so it has to handle that. The problem here is, so analysis on big data, it gives a better results, but the data sets are large and complex, which are difficult to process. For that, we need a solution. So that is a distributed computing or map reduce. For that, a software platform is a Hadoop. Okay. So what actually I mentioned previously, they are present here. One is HDFS, the distributed file system. Okay. Okay. So which stores the data that is distributed in different number of machines and so treat them as a single machine. And the map reduce, This framework is helpful for performing the task or processing in parallel. Okay, with the help of these two, HDFS and MapReduce, these two are present in Hadoop. Okay. Now the Hadoop is a platform. So what we discussed previously, to do that, that means a parallel processing, that means parallel computing and distributing the data across multiple machines. So we can do that with the help of Hadoop. Okay. So why Hadoop is useful in the sense, it is scalable. That means, so even the data size is gradually increased in every day or every second, it can so scalable to such higher data, and it is economical. Okay, here we are not using the high-end computers, just we are using commodity hardware. So, and the data is distributed across normal personal computers, that to a group or cluster of computers. Okay, it is very economical and efficient. Okay, so by distributing the data, so here we can process it in parallel. So on the data nodes, so where actually the data is located. Okay, it is very efficient, very simple also, and it is reliable. Okay. So here we are making a cluster of machines. So the data is never lost, and here we are maintaining backups. Okay. Here one factor is there. The factor is uh, that means redundancy of data is there. So that means we are maintaining 2 or 3 copies of data. If any one of the copy is lost, we can take another one as a original copy. Like that, some more copies are available. That's why there is no data loss. Okay. So, and this is about the Hadoop. Okay. So what is Hadoop finally? So Hadoop is not a big data, but Hadoop is also not a database. It's just a platform or a framework, okay, that allows the users to write their test distributed systems. Test distributed in this system in the sense they need to solve the problem. To that, they write one code. That code is distributed across various number of machines which are there on the framework. Okay, and it is efficient in automatically distributing the data and work across the machines. Okay. So this is a platform where we can solve our big data problems. Okay, and this is a Hadoop ecosystem. Okay. So actually the data is stored. So how the data is stored in the sense, with the help of Hadoop's distributed file system, it is a file system where data is stored. And the MapReduce framework or MapReduce, this one is used for job scheduling and the execution of the jobs. And we can use various tools to do our processing on the data which is stored in the HDFS with the help of MapReduce, either ATL tools or BI reporting tools. We can also perform the database management systems called RDBMS. Okay. So this is a Hadoop ecosystem. And so big data analytics, okay, the last one. Here, by using this big data, we can perform analytics. That means we can examine large amounts of data and we can gain some knowledge from that data. And we can get the appropriate information from that very huge amounts of data. And it is able to identify the hidden patterns and unknown correlations. And so it is very effective in case of marketing and customer satisfaction and to the increased revenue. Okay. So that's about my presentation on the big data today.
Okay, thank you, sir. Thanks for your presentation. I asked the participants, so any queries regarding this topic, you can ask to the resource person.
Sir, Prasad Reddy, sir.
Sir.
Can we treat as big data more than 1 GB data? It's
not more than 1 GB, sir. Even more than some petabytes.
Petabytes, okay.
Yeah, very big in size. Even a single file is having a size of some petabytes.
Okay.
But that file is divided, sir. That file is divided, and it makes as a single part. That means one file is divided into 100 or 200 number of small parts, and each part is assigned to one machine. So actually, our normal computer is able to process that means some number of GB size. So 1 GB or 2 GB file is easily processed by our normal computer. Like that, a heavy work. So 200 terabytes or 200 TB data is divided into So small parts, that means 200 or some 100 parts. Each part
Oh,
occupies some GB data. That part is assigned to one machine. That machine perform the processing on the processing of that's a piece. Like that, all
oh,
100 pieces result is collected, and it is the result of the entire big file processing.
thank you. Uh,
Okay, sir.
any faculty? Yeah. Sir, can you have online platforms for big data analytics?
It's online platform, sir.
Yeah, to perform analytics on big data.
Actually,
So
so big
online
data.
platform. Yeah.
So I know about big data
Okay.
technology, sir. I'm
Okay. Okay. No
not
problem.
having any
Okay.
knowledge about analytics.
Okay. Sir. Thank you
Okay,
for
sir.
your nice presentation.
And so thanks for CRA, sir, to give such kind of opportunity.
Thank you.
Okay, sir. Thank
Okay.
you, sir.
With this,
Thanks for
yeah, close. Sir.
Okay,
okay,
sir.
sir. Thank you, sir, Prasadji, sir. Thanks
Thank you,
for
sir.
giving nice lecture on big data analytics, big data technology. Okay, I thank all the participants for listening this session. Okay, sir. Again, we join tomorrow on same time. Okay, thank you, sir.
Okay, sir.
Thank you, sir.